All right. So I just want to give everybody a heads up. So today we're gonna solve two use cases, and one of them is called Starbucks, and the other one is called deposit. So if I go into deposit, oh sorry, Starbucks. So we'll start with Starbucks, and I have a bunch of files in this subfolder, including an Excel. I just create a copy of it. So I will work off this copy. And you should also see a Starbucks SQL script. And there's another one, Starbucks pivot on pivot.sql. So we will start with the Excel, like always. I just want to use the Excel to make a point, to illustrate, some of the concept, and that will be very, very important in data modeling. And also I use the Excel to make the logical thinking clear to you. So let me just go to the Excel, the first one. Please join me if you want to, just manipulate the Excel. By all means, just follow me. If not, you can just sit back and watch. I think this might be a good approach too. So you just watch how I do it, and then after the session, you could take your own time. You can watch the recording and try to reproduce the project at your own pace. And if you have any questions, please feel free to use the Q&A, and I will go slow, but I will not stop until the break. So during the break, I will look at the question and answer session and try to answer some of the questions you raised. And toward the end of today's session, I will look again at the Q&A and to see if you have more questions. And we have several TAs to support this, and you can use Google Doc to raise your question. It's going to stay there permanently, and you can also use Discord. And but the issue with Discord is when too many people are trying to post messages, your message could be pushed into the conversation history, and it's hard to trace. So if it's specific to the content of the course, and I would encourage you to use Google Doc, and it's more convenient. Where is the Starbucks subfolder again? If you have logged in to our learning portal, and you should be able to find a big zip file, and all the materials are saved into the subfolder, and then multiple subfolders are combined, compressed into one zip. So if you have that zip file unzip, you will see multiple projects, each project in a subfolder, including this one, including Starbucks. So, all right, let's get started. So everybody has gone to Starbucks at one point, and usually when you walk in, and this is what you look at. So it's the menu, on the wall, or maybe on TV, on the screen. So what you see is a two-dimension table. Once again, I use the color coding, and I use blue to represent dimension, and I use green to represent measure. So if you look at this table, it's essentially a two-dimension table. And the first column, you will see, and I call this food. It's basically different coffee. And if you look at the first row, it's actually the size of the coffee. So this table, you can call this table product, because any combination of the food and size is a different product. I don't know if you get it. Because, for instance, coffee latte, and you could have coffee latte in a tall size cup, or grande, or venti, and then the different cups, of coffee latte actually represent different products, and the price is different. And so essentially, a product is a combination of food and size. So interestingly, this is also how we check the price. So for instance, if I always drink coffee mocha and grande size, let me just highlight this in red. So this is my favorite product. Every single time I walk into Starbucks, I order this, and I don't necessarily remember the price. So when I walk in, I would do VLOOKUP. For instance, I will just look at the food, and I will just go down until I see coffee mocha, and then I will go across, because I'm actually looking for the grande column, right? So tall, grande, venti. So this is the grande column. So I will just go across. Here we go. So this is the price, right? So this is essentially VLOOKUP. I'm going to actually do this. So for instance, this table, this menu, is really for you to search and filter, if you will, and sort and rank. And you can do all these operations on this table. And just because the data is structured this way, I'm going to say this data structure is actually very, very bad. I want to say this upfront, but I will explain why it's bad. And this is actually better. But let's just leave with this, because this is what we see on a daily basis. Every single time you walk into a Starbucks store, and this is what you see. And you get used to it, so you don't really feel this is bad until you become a data analyst. Okay, so just because the structure is bad, we invented all those functions and formulas to deal with it. So for instance, we have the lookup. I'm pretty sure some of you have heard VLOOKUP, and many of you have already used it. And there's another way to search and find the right price, which is called index match. I think fewer people have heard of index match, and I will explain why index match is actually better than VLOOKUP. And I'm going to demonstrate this to you. But before I do this, before I show you how to use VLOOKUP, I'm going to show you a different way to use VLOOKUP. Usually, the students who work with me, and they are under the impression that Eric intends to make things easier for them. Okay, so it's the same thing. I'm going to do a few things. And later on, you will see this actually makes VLOOKUP or index match a lot easier. So first of all, I'm going to use range to name the whole table. So all you need to do, you can actually press Control-Shift together and then right and down. Oh, this is a small table. You can just select the whole table and go inside here. So this, how come I already have this? Maybe I already did this. Just give me a second. Let me delete all of them. I do. I actually have all this. Let me delete them. I really want to show you from 0. Okay, so let's start from scratch. So I put my cursor in A1 and press Control Shift and then right and down. So I'm going to call this product and strike enter. And then this is a row header. So I'm going to call this food. Okay, and this is a column header. So I'm going to call this size. All right, and I'm going to name 3 more ranges. So this column, I'm going to call it tall. And this one, I'm going to call this grande. And this one, I'm going to call it venti. Okay, so if you click this, you will see all these ranges. And the other way is go to formula and click name manager. And you also see these ranges. And it's a very good practice that you use ranges, and that will make the reference a whole lot easier. And you will see when we start using the VLOOKUP. So for instance, if I really want to find out my favorite coffee and the price of my favorite coffee, so I'm going to use VLOOKUP first. So what I usually do is, let's just type VLOOKUP. VLOOKUP. So press tab. What I normally do, so first of all, I can just type the lookup value. I can type, what is it? That's cafe mocha, right? Cafe mocha. Okay, then what I usually do is just select from A1 to D10, but since I have already created the range, I'm just gonna type product. And this is perfectly okay. So to use VLOOKUP, we have to count from this column 1 and 2 and 3. And so this is where the grande column is. So it's the 3rd column, from the food column. So here you can type 3. And then usually you will type 0 or false. So it becomes an exact match. So let's do this. So you get the price. It's actually pretty easy. And it's also very clean. You see, this is the lookup value. So this is the lookup value. And this is the range of the entire data set. And this is the 3rd column from the left. And 0 represents exact match, right? Okay. The drawback of VLOOKUP is, number 1, you can only look to the right? So the lookup value has to be found in the leftmost column. And you cannot look to the left. So you can only look to the right. So that's one thing I don't like VLOOKUP. And the second reason I don't like lookup is, what if I delete a column, or maybe if I have another size, I insert a column, so it's not 3 anymore, right? So if I change the structure, that will create problem for this formula. so the VLOOKUP will not work anymore. So that's the reason I don't like VLOOKUP. And the second way for you to find this price is index match. Like, it looks complicated, but it's not. And it's a lot better. So in fact, I'm going to show you how to do two-way lookup using index match. So first, we want to use match to find the row and also find the column. So I really want to find out, the row number for Cafe Mocha. So what you need to do is type match. So first of all, you need the lookup value. So that's Cafe Mocha. So I'm going to type Cafe Mocha. And then you need to find the lookup array. So that should be the first column. I already created a range for this. It's going to be food. So I will use food. And then what's next is the exact match. So I'm going to use 0, and that's it. So you can close it and type enter. So what does it mean? So 5 means it is the 5th row. So if you count from here, 1 and 2 and 3 and 4 and 5. So this is where you find Cafe Mocha. So that's row 5. And the second one is the column number. So again, you're going to use match. So just type match. Okay, so this time I need to find what? I need to find Grande. So I'm going to type Grande. And I need to find Grande from the size row, from the first row. So this, once again, if you recall, we created a range for that. So it's called size. So I'm going to type size, right? And comma, and then you can choose 0. So we will get the exact match. And let's close it and type enter. So 3 means if you count from the leftmost, so this is 1 and 2 and 3. So it's the 3rd column. So it's the 5th row and the 3rd column. So once you determine these two and the intersection, you can find the price. So it's going to be really, really easy. So the 3rd step is index. So you will type index. Okay, so what you need to do is first, you will need to put in the array. So this is going to be the whole table. So you can just type product. And then the row number should be index. Or you can put this and then the column. And after that, what is it? I think that's it. You can just close it and you get the price. So once again, you use 2 match and 1 index, and you can actually embed the formula into the 3rd one. So I'm going to replace this with the formula. And also I'm going to replace the column number with the formula, and that's it. That's it. So I can use the index match to find the price too. And the 3rd way is called XLOOKUP. I personally like XLOOKUP too. How it works, it's all, you can do horizontal, you can do vertical, no problem. So usually we're used to vertical. So what you can do, so XLOOKUP, X, you can do V, you can do H, and so we can use X to represent both horizontal and vertical. So what you need to do is you type VLOOKUP. All right. So what is the lookup value? The lookup value is going to be coffee mocha. And then you will need to put this food column over here. So you can just type food. And then what you need to do is just to put, you know, the size column in here. So in this case, it's going to be grande size. So I'm going to, so this column is also defined in a range, and it's called grande. So I'm going to just use grande and comma, and I need the exact match. So I can type 0. There is a bit more. Anything else? I think that's it. Oh, there is a food grande 0. Let me just double check. Oh, I think I made a mistake. So if I come from here, food and grande, the exact match, it should be false or 0. That should be okay. And then, yeah, that should work. And it doesn't work. Just give me a second. Well, I think there's something. Enter too many arguments for this. I tested this before. I'm pretty sure it's working. Just give me 1 second. Oh, I put VLOOKUP. Sorry, this should be XLOOKUP. And then let me try this again. So here, if not found, you can just put a warning and not found, for instance, and comma, and then you can do exact match, which is 0. Yeah. So this will return $3.95. And this you can skip it. So you can just skip it. And then you have the $3.95. Do you like it? I don't like it. I hated it. To be honest with you, let me just do this. Insert. Let me just insert a shape. How can I insert a shape? Yeah, let me just insert a shape. Let's do this. Okay. So I'm going to say, I hate it. I don't like it. This is totally unnecessary. UNNECES. Unnecessary if data is better structured. Yeah, this is what I want to say. And this is also what I want to show you today. Okay, so if the data is structured this way, it will be, our life will be so much better. So I want to show you this versus this. How do we get this? It's actually pretty easy. So what you need to do is you can just type, for instance, you can type this over here, right? And then you can type these two. So this is what, this is tall, right? So I'm going to insert a column. So I'm going to put this as tall. So this is essentially tall. But the second one is this. And I'm going to copy these two columns. So you see, I'm repeating the row headers. And once again, I'm going to move this here. And this is actually grande. So starting from cafe latte. So there's the third one. Once again, I can just copy this and this. Right. And let me just move this to the right. And this should be venti. So starting from cafe latte. Right? So if I were to complete this table, I can put this size. This is size, and this is price. So this is food. If I were to complete this, it's actually, there's a trick you can do. So you can select this, and then I think it's Control G, and do special, and put blank. So it will select all the blanks, and then you can type. You can just type equal, and then equal to the immediate first, and then I think it's Control. Oh wait, just 1 second. So you could just type. I think it's Control Shift Enter. Oh, still 1 second. It's just a little trick. Anyways. Oh, it doesn't work. That's fine. So all I'm trying to do is you can copy this down. It's called fill down. Yeah. So I was trying to say this and this are just different presentations of the same data. Okay, why is this important? I want to show you why this is bad and this is good. So let's just go to the second page. So what I did, just give me 1 second. Let me bring up something. All right. So this is essentially this table, but what I did, I just removed. I removed the actual value, and I just put a serial number over here. So this is the Starbucks menu, and it shows you data comes in different shapes. So this is the wide shape, and this is the long shape. All right. And I want to tell you that the wide is natural. The wide shape is natural for humans, and the long shape is natural for machines. And it doesn't matter if it's wide or long, but they're essentially two different presentations of the same data. All right. So now I want to point out to you these two different shapes, because this is going to be the most important concept of data modeling. So in order to explain this concept in a simple way, I'm going to put these two shapes side by side. And I replace the actual value with the serial number. And you can clearly see, you can still see two dimensions. Food is one dimension, and size is the other dimension. And you could also see food has line distinct values. Those of you who remember distinct and unique, this is both distinct and unique, right? So if you come back here, and these are distinct and unique. So food has 9 distinct values, and size has 3 distinct values. So line by 3, you should have 27 values, or in this case, we actually have 9 by 3, 27 different products, and they could have different prices. Okay, so on the right-hand side, you also see 27, prices, and every single one is for a product, and every product is a combination of food and size. Okay, so I'm going to show you why this is better than this. So imagine, humans are quite familiar with this, the 2-dimensional table, and it actually has a name. It's called crosstab, right? And food is in the row header, so this is a row header, and size is in the column header, and the price is in the cell. And if you pay attention, right, and you will see the problem with this shape, because all these values are actually a size and price pairs, right? So you see, size is that actually embedded in the column header. That's bad. And second, price is in 3 different columns, and that's also very bad. Imagine if you want to perform any operation on price, let's say if you want to find average price or minimum price or maximum price, you will need to handle 3 columns instead of just 1, right? Whereas the long format, it is very, very clear. So you see, every dimension has its own column, and every measure has its own column. So I'm going to repeat this because it's so important. So every dimension has its own column, but only 1 column. And every measure has its own column, but only 1 column. And it makes aggregation, calculation simple and easy, because you only need to deal with 1 column. Just to further illustrate the difference between the two, I want to ask you to imagine, this is just the 2 dimensions. What if we have 3 dimensions? Let's have 3 dimensions. So I'm going to, just give me 1 second. I'm going to make this food, size, and months. So let me also color code months, so to be the 3rd dimension. So we have 3 dimensions, food, size, months, and 1 measure price. What do you mean? So let's say for a given store, the price actually changes every month. And so every month we will get a different table like this, right? How do you want to present the price or the product table? So some of you might say, oh, then we will need to have different pages. Or within Excel, we could put, this in different sheets. So it's essentially, let me just illustrate this. So let me insert a shape like this. So maybe this is 1 page. Let me just. Okay. Oh, you know what? Let me do a different one. Let me insert a text box. That's easier. So this is, let's say this is January, right? So because price change every month, so this is February, and this is March, and this is April, and this is May. So let's say if we want to capture a year, 1 year, the price changes, I will need to have 12 sheets. So what about 10 years? And then I will need to have 120 sheets. And so you can see that humans are already struggling. What about the long format? Is that easy? Oh, it's so easy. So what I need to do is I will just add, oh, it's not here. I will just add another column, right? I will just add a month here. So if you say this is January, and then for February, I will just add to the end of it. And then March, I will, add to the end of February. So it's going to be very long, but the structure wise, it's going to be really, really simple. Am I right? So I think you get it, right? So what if we make this even more complicated? What about 4 dimensions? So price by food and size and months and store. You see, I'm just adding the dimension. So let me just do this one more time. So this is another dimension. Some of you probably can guess, we have lots of Starbucks stores in Ontario or even in Canada. I think we have close to 500 Starbucks stores in Ontario and 1,400 stores in whole Canada. So what if we need to capture the price for every store and for every month? And so it's going to be, you can multiply this and you will get a lot. And imagine for a year, you have 12 months and then you have 500 stores. I don't know, humans, how are you going to store all this information? And because most of the time we're okay with 2 dimensions, the 3 dimensions, you add, page after page, we're struggling. But if you add another dimension on the store, it's almost impossible, right? Some of you may say, let's have 500 Excel spreadsheets, and then every Excel is a store, and every Excel has 120 sheets, and every sheet is a month, and then on every sheet you can have that food and size and the price for just for 1 month and for 1 store. So this is impossible to capture the information. But what about the long format? It's easy, right? I think as you guessed it, you can just add another column and you can put store. And then you can just add, now after you finish a year for 1 store, and you will do the 2nd store and the 3rd store, and it's no problem at all. And once again, the shape of the data is very long, but structure-wise, it's the same structure. It doesn't get more complex, and so it's a lot more scalable. In fact, you can keep adding the dimensions, and you don't feel this is the big problem. It's just another dimension. And I don't know if you guys get it. And this is just one best way to organize data. Okay, and there's another reason we prefer the long format. So for instance, if you look at this table, for instance, cappuccino, or maybe let me see, drip coffee. Now, for instance, if we don't have venti size, so for this format, it's going to be a whole, right? So You will see a hole there, maybe a hole here, only because we don't have that. But you still have the placeholder. But for the long format, if you don't have one, one product, you can just delete it, right? You can just delete it. So for that reason, this may not be a big issue for you, but if you have too much data, it's going to be a huge issue. And this structure with a lot of holes is a total waste of storage resources and computing power. And this is much better because we can simply delete all those nulls or blanks. We don't need them, and it doesn't affect it doesn't affect the structure. In fact, it makes it just a lot easier to store and to compute. And it will make it faster. It consumes less memory. So I don't know if everybody gets it so far, but from now on, we can move to SQL. I think this is a very good understanding, and it's ready. We can move to, I don't know if you are using MySQL or SQLite. I think to be safe, I'm still going to use SQLite. And those of you who were with me, the previous two sessions, you can just type SQLiteonline.com, and then you will be in business. So when you refresh this, you will see a demo table. If you don't need this, and you can just right-click and drop it. Yeah, you can drop the table. And you can delete this query as well. So we're gonna create two tables. So the first one is a product table, and the second one is a sales table. But before we even do that, we need to create the database, but not in SQLite. If you're doing this in MySQL, you need to do that. So let me just bring up MySQL. You should always do the 3 lines over here. So drop database if it's Starbucks, create database, Starbucks, and use Starbucks. So let me just run this 3, and let me just clear the output. So if I refresh this, I should see Starbucks database created. Okay, so let me just run this one more time, and you will see the first line says, drop database if it exists. We didn't have a database called Starbucks, so this one. And the second one, let's create a database again. It's called Starbucks, and now we can use Starbucks. So after this, you have empty database called Starbucks, and there is no table. You can see that. So from now on, you can create the table. So let's come back here. It's pretty easy. You will need to get used to the syntax. First of all, you can just copy, and after a while, you will memorize it. So it's create table, and the table name is product. And then you can type opening bracket and closing bracket. And then you break it. So move down the closing bracket. So within the opening and closing bracket, you can put in the columns you need. So if you recall, if I go back here, we need 4 columns, and product ID is something we add later on. So before that, we only have food and size and price. And once again, we like this structure because it's a long format, and every column every dimension has its own column, but only one column. And every measure has its own column, but only one column. Okay, I'm repeating this the whole time and just to make an impression in you. So every dimension has its own column, but only one column. And every measure has its own column, but only one column. Okay, so it's product ID. Once again, we have 27 unique products. So we can just give them each a number, all the way from 1 to 27. So it's product ID, food, size, and price. And if you look at the data type, this is integer, this is string or text, and this is text, and this is decimal, right? Or float. So we're gonna use flow. So if we go back here, we need 4 tables. So it's product ID, and it's integer, right? And we use comma to separate them. So this is food. Food, we can use varchar. So it's varchar. So it's a string, but the length of the string vary. The maximum, let's put 255. That's a big number, but it allows any length less than 255. So once again, we put a comma, and here let's type size, and again we use varchar and 255 and comma, and we can say price. So price is decimal, or you can use float. Okay. Now that's everything, but we want to do one thing. We want to define the primary key. The primary key is actually product ID. Why? Because it's unique. If you go back here, the product ID is unique. And every ID represents a product, and this ID appears only once and occurs only once in this column. So it's unique. You can uniquely identify each product. So if I go back here, and this basically defines product table. So this is really good. You know what? Let's just put some comments. Maybe let's create schema. All right. Schema, we need to create tables and then insert the values. So let's create the second table. But before we create the second table, I want to illustrate the second table using Excel. So it's right here. So I'm going to tell you a story. So imagine yourself, and today is Wednesday and tomorrow is Thursday. So tomorrow morning, lots of you like coffee. So you walk into the office, and the first thing you want to do is just go downstairs and get coffee. But you are in the mood. So you tell your co-workers, maybe 6 of them, say, I'm going to buy every one of you coffee. So they just go with you, and 7 of you, 6 co-workers and yourself, 7, you go down and you walk into the Starbucks. So let's say they just opened, you're actually the first customers. And once again, you said, I'm going to buy you all coffee. So you stand in a line, there's 7 of you, and each one has your own favorite coffee. But for some reason, all of you like mocha, just different size. One of you like the white chocolate mocha. So you order your own drink. Okay. So over here you can tell. So one of you order a tall size coffee mocha, and 2 of you order a grande size coffee mocha, and 3 of you order vintage size coffee mocha, and 1 of you order a tall size white chocolate mocha. Okay, so if you add them all together, 7 cups. All right. So after you all order your own coffee, and then you say, let me pay. So you swipe your credit card and you pay, and the employee give you a receipt. So this is the receipt. And that receipt has a number printed on it because it's the first sale for that store. Okay, so I just want you to understand the data structure over here. It's just like when you go grocery shopping, it's the same. So let's say you go grocery shopping once every week and you put lots of stuff in the shopping cart, and then you check out a mountain of groceries. So after you finish paying, and you will get a receipt, and it's a long receipt. It's a long receipt, but the whole receipt represent one sale. So I hope you understand that. So that's one sale. So one payment, one receipt, and one sale. So this is just a different representation of the same table. So over here you see the sale number is the same. It's 1. But however, you have 4 lines. You have 4 lines. That's because you actually purchase 4 different products, and it's the same thing when you go grocery shopping. So you I don't know what you buy. You buy maybe 4 packs of instant noodle, maybe some vegetables, some fruits, and every product will show up in one line. So over here we just put a line number, so you can see in this case 7 of you purchase 4 kinds of product, right? So 7 of you purchase 4 type of products, 4 products, but with different quantity, right? So you purchase 4. So what is this 4? So this has to do with the product table. So if you look at the product ID being 4, that's essentially coffee mocha tall. So if you look at 4, that's coffee mocha tall, right? So you purchase 1, and second line, that's a different product. That's product 13. So 13 is coffee mocha grande, is coffee mocha grande, and you purchase 2, and then 22, and then 5. So 3 for 22, 1 for 5. So I hope you get this structure. So the 7 of you, you purchase your coffee, and you paid for all of you, and then it's 1 sale, and 4 lines because 4 product, with different quantity. If you really want to calculate how much you pay in total, you're going to do this. Just bear with me. Okay, so first of all, you will need to get price from where? You will need to get price from the product table, correct? So if you use if you use X lookup, it's going to be easy, correct? So you can just type X lookup. So food is going to be here, coffee mocha, and then you can just type foods. So that's where coffee mocha can be found. And then you go across, and then you just need to go to the tall column. So over here, you should type tall, and then what? And then you can, if not found, you just skip that, and then 0. Right? So that's 3.25. So I can just copy this down, except I will need to change tall to grande. So this is grande. And this, I need to change tall to venti because it's a different column. And this is a different column. This is also tall. So that should be fine. So these are the price. So If you really need to find out the subtotal, that should be easy, right? It should be the quantity times the price, correct? And then you can just copy down the formula. And now you can just do a grand total over here for the first sale. So what you need to do is sum this. So it's $27.08, 80 cents. I think you got it, right? You got it? Let me just save this. So then let's go back to SQLite. So now we need to create the second table. Let's type create table and sales. So opening and closing bracket. And you should type semicolon. So there's a semicolon here. And you can break it. And within the opening and closing bracket, you can specify the columns you need. So this should be a sale ID. So this is integer. Okay. And we also have line ID. And then we have product ID. It's just a bunch of ID. And then finally, you have a measure. So that's quantity. Quantity should be whole number. So that's also use integer. And that's it. But now we want to define the primary key for this table. So here is once again, so what is a primary key again? Primary key uniquely identifies every row. So if you go back to this Excel spreadsheet, what is the primary key? Which ID is unique? Is this unique? This is not, right? Is this unique? No. So you see, we have several customers. So this is the first sale, second sales, the third sale, and fourth sale. And in fact, if you want to understand, so standing in the line, this is probably just one individual. And so one receipt, but just one coffee. And then here, another individual, one coffee, and then another one. So this is one sale, but actually they purchased 4 coffee, right? And once again, different product, different quantity. Okay, for that reason, you can tell that every single cell has at least one line. So you see a 1 here and 1 here, 1 here, right? And this is not unique. You know, you see 1 repeat, right? Is product ID unique? No, because you know even you yourself can purchase the same product multiple times. It's going to repeat for sure, and different people or in different sale, they're gonna purchase the same product. So what do we do? None of this is unique. But one thing you need to remember, primary key doesn't have to be 1 column. So primary key can be more than 1 column. So in this case, if you use sale ID and line ID together, and they become unique, why? You can see. So you see 1 1, 1 2, 1 3, 1 4, 2 1, 3 1, 4 1, 4 2, 4 3. Is it unique? It's unique. If you put them together, and then you have a primary key, right? So this is really, really important for you to remember. And primary key doesn't have to be 1 column, so it could be more than 1 column. So in this case, in the case of Starbucks, And in the case of any retail outlet, you have the same structure. You always have a sale ID in one column, and then you have a line ID in another column. So then you have the details, right? So every line you have a different product, and you can put the quantity beside. So with that, we can go back here and we can define primary key being two keys. So it's sale ID and line ID. And then this is the tricky part. So we want to define the relationship between the product and sales. And this is probably the simplest data model. We have only two tables, and this is actually a dimension table. This is what, right? Product. If you recall, dimensions could be 5W and 1H. So in the example we just explained over here, and do we have that? So food is what? Once again, so maybe food and size together, that's product. That's what. And then you have months, that's when, and store, that's where, right? So you realize you almost always have time and space. You always have, store and months. And you always have calendar. You always have geography. Okay, so let's go back to our example. So this is just one dimension, what, and then the sales is the fact table, and you should find the measure over here, which is quantity. Okay, so for that reason, we need to find the primary the foreign key over here, define foreign key over here, which is FOREIGN, foreign key. So this should be product ID. So remember, foreign key is always in relation to primary key. So when you define foreign key, you just have to reference the primary key. So you can just type references and then the table and the primary key. So the table is product, and the table, the primary key is inside this table. So you put within bracket product ID. That's it. All right. So let's run this too. I think it runs successfully. So coming up next, we need to insert the values. So we need to learn how to construct or reconstruct the database. So please bear with me. I'm going to take time and create the table and insert a value. So you can just type insert into, and if you want to insert all the columns, you can just type the table name. Otherwise, you will need to specify which column. In this case, we're going to insert values into all columns. So I will just put the table name. And second line, you can just type values, and then you can put the rows after rows. So what you can do, I'm going to make this easier for myself. So what I did is this. Let me just try to recreate this. Give me 1 second. So let me try. Over here, I can just type. So we need a opening bracket. So I can just put opening bracket within quote. Okay, then I put an and sign. The and sign is after this. I can just put product ID 1, right? I can just put 1 here, and then I can type So after that, there should be a comma. So I can type comma within quote, and after comma, we should have a single quote because I wanted to put coffee latte within single quote, and then I can put another double quote, and then you can put and then you can add this. Then after this, you can put an and sign again, and you will need to put within double quote. What do we need? So it should be single quote, comma, single quote, and double quote. I hope I didn't lose you. But now you put an and again, and you will need this. All right, so then you will need an and sign, and then what else? Double quote, and you need a single quote, comma, and then you don't need single quote because price is going to be a number. So you can just put a double quote over here, and then and the price. Okay, after that, you still need a closing bracket, and put closing bracket within double quote. I hope I get it. Yay! So this looks correct. Yeah. So then after you have this, you can just copy it down. Oh, you know what? Let's also put the comma over here. So we can separate, the rows with a comma. All right. Now you can just copy this whole thing to SQL. Let's do that. But the last line, you can change it to semicolon. I hope I got this right. Let's run it. Yeah. Okay. And then we need to insert value into the second table, which is sales. And once again, what is now we need to put values. And below, you can just put row after row after row. So if you go back here, and let's do the same. These are all numbers, so you don't need to wrap the number within single quote. So it's going to be easier. So you will need opening bracket. So put opening bracket within double quote, and then the first number. Sorry, we always need to put and sign, and then the first number, and then and sign again, and then we can put comma within quote, and then the second number, and then we put comma within quote. The third number, sorry, I always forgot to put the and sign, and the third number, and sign, comma within quote, and sign, the last number, and an and sign, and closing bracket, and comma within quote. This should be right. Yeah, this is right. So let's just copy paste it down. So let's copy paste the whole thing back to SQL. And let's replace this last comma with semicolon. Okay, you know what? We should always indent this to make it look pretty. So this one too. All right. Okay, we haven't run this. Let's run this. All right. Just to check, if we get the numbers right. So we do have 2 new tables created. So what you can do is you can select star. Very easy, right? Remember, from product and semicolon. You can do this, run, so you get this right, and 27 of them. And you can just change product to sales. Oops. This is pretty easy, and run it. Yeah, so you got this sales table. So does anybody have any questions about this? Okay, so it's 8:16. Let's take a break, and so we'll come back at 8:26. And during the break, and those of you who would like to stay, I'm going to try and answer some of the questions that you posted on Q&A. All right, so take a break. All right, so what questions do we have? Let's see. From Shruti, I think the column index number should be 3. So I think you were trying to help me with the Excel. XLOOKUP instead of the VLOOKUP, I think. Yes, I use VLOOKUP. That's why the formula didn't work. Sorry, don't have the second table. So Nina, I think later on you can, in fact, that's one question I got. I hope everybody got, the first part of today's session. We do have the one last question. Where do I find the table included in the second sheet? If you're referring to this guy. Okay, so if you don't have that, you should have that. Oh, you mean this one? Oh, if you don't have this, I'm going to post this. I created this just today, just to help with the explanation. And I will repost the Excel today. In fact, let me do it now. Let me just do a few things and I will save. Okay, let me save it and then I will post it on Discord. Hope you're okay with that. So let me go to Discord. Okay. So if you're on Discord, you can download it from the Data Fundamental channel. All right. Q&A, do we have any other questions? Got some hard time with XLOOKUP, always get, I know. This is not a course for Excel, but I think I should show you some of the functions and formulas we use. In fact, if you use VLOOKUP, index match, XLOOKUP a lot, that's a sign that you're working with bad data. I hope if you walk away today remembering this, you get something from this session. We need all those formulas and functions only because the data is in a very bad structure. So in a moment, I will show you if the data is normalized, for instance, and if the data is in the long format, meaning every dimension has its own column, but only one column, and every measure has its own column, but only one column. If your data is structured in a long format, it's so easy. You can just, use the where condition to specify the dimension equal to certain value, right? So that's essentially what you do when you are trying to determine a value. You have to specify the dimension in order to determine the measure. You have to specify the value of the dimensions in order to determine or control the value of the measure. Don't you realize now? And all you're trying to do, with that product table is you're trying to tell the table, which value in each dimension you are trying to look in order to find the value of the measure, right? So search and filter and sort and rank becomes so easy if you have data well structured, and you can just use SQL to manipulate. And the SQL query allows you to search, to filter, and to sort and to rank. And we did a lot of that in the first and second session. And today's session, we are just gonna, use a very simple case, Starbucks, to show you the full process, starting from creating the database and then creating the tables and then insert the values. And after we finish building the database, and we are able to, do the same kind of operations. So we can search, we can filter, we can sort, we can rank, but using SQL. And you can see it's just so much easier to use SQL to work with well-structured data than using VLOOKUP, index match, or XLOOKUP to work with unstructured or badly structured data, right? Is there any exercise we may practice on? I will give you exercise to practice on, but first and foremost, I want you to, reproduce Starbucks and reproduce the second use case is called deposit. So we'll finish Starbucks and then we'll do deposit. Okay, so if you guys are okay, we can start now. All right. So let me just bring up my SQLite. So what we want to do next is, first of all, I really want to show you in my SQL the data model. So even for two tables, after we connect them, we have a data model. So let's do it from the beginning. So I think we already did this. So let's create the product table. So it run, it's good. Let's create the sales table. All right, it also run, it's good. So let's insert the values into the product table. It's also good. Let's insert the values into the sales table. It also run. Let's refresh the schema. If you expand tables, you see these two tables. And if you just go to the third icon and click it, I think you see the product table populated with 27 rows, and it looks perfect, right? So let's take a look at the sales table again. And so over here, you see 4 columns. So for sale ID, these are 9 ID and product ID and quantity. That looks good. So now you can actually, did I show you? Oh, wait a minute, I go to a different script. So I put it over here, entity relationship diagram, or ERD. So you can actually see the ERD by going to the menu. Just go to database and then reverse engineer. So you can go to the database and then reverse engineer. I did this last time, with Coffee Chain, but I'm gonna do this again so you can see how we can get the ERD working. And click next. Click next. So now we have several database. And you just check the box Starbucks and click next and execute and next. I know it looks very simple, this data model, but it's a data model. Again, I can put dimension table at the top and the fact table at the bottom. So you can see there is a relationship between the product table and sales table. And we created this relationship by connecting product ID to product ID. And the product ID in the product table, you see a golden key before it, so, because that's a primary key. And you don't see a golden key before product ID, so this is a foreign key. But in the sales table, you actually see 2 golden keys, one before sale ID and the other one before 9 ID. Remember, the primary key doesn't have to be 1 column. The primary key can be 2 columns. So in this case, the Starbucks case, and in the sales table, when you use sale ID and 9 ID together, and they become unique, okay? So once again, when you have this 9, you can see it's a one-to-many relationship. And because this 9 touched this table, just 1 point, 1 spot. And this 9 touched this table, you see 3 little lines here. So you touch 3 spots. So it's a one-to-many relationship. So that, explain this well, right? So once again, I think you've learned, if you define the table property, meaning, you can define the data model through programming, right? And that's because you define the primary key over here, you define the primary key and foreign key over here. And so, with the programming language, you're able to create the same data model. So with that, we're going to solve some problems. So let's go back to SQLite again. Okay, what do you have on line 20? Insert into, okay, let's just go back here, line 20. Oh, you probably are referring to SQLite, right? Yeah, insert into product. Yeah, so this is what we use to insert the sample value to the product table and sales table. So starting from here, and we'll work on the first problem. Remember how we comment on SQLite, which is type --. So first business question is, what's the price of grande coffee mocha? I think that's the same question over here, right? Yeah. What is the price this is my favorite coffee. So what is the price of a grande coffee mocha? But this time we want to solve this problem using a SQL query. So how do we do that? And once again, it's very important to understand the question fully and then break down the process before you start coding. And remember logical thinking. So even though we practice this using Excel, so this process might be intuitive to you, but it's still worthwhile for you to maybe break it down. So first of all, when you see the business question, what is the price of grande coffee mocha? I encourage you to break it down into dimension and measure. So what is the dimension? What is the measure? So there are two dimensions of one measure. I think everyone should remember the food and size are two dimensions, and the price is one measure. And all of you should remember the food and size and price, they all come from one table, which is the product table. So that makes things a lot easier. So in fact, we need to do some filtering because in mentioned grande, that's just one value of size, and coffee mocha, that's just one value of food. So once we put in the condition, put in two conditions, we should be able to determine the measure. So let's start coding. And the skeleton is very simple. So in this case, it's the simplest of the simplest. So you can just type select and from, and then where. Okay. So we know we just need one table, which is the product table. And then we want to do filtering first because with two dimensions taken care of, and we can just put the price into the values. If you remember the pivot table, right? So we use the slicer to do filtering, but in SQL, we can put two conditions in where statement and we combine them with an and. So first is food equal to cafe mocha. We put an and the second condition is size equal to grande. And that's it. So what you need to do is put price after select. Remember the golden rule, it says, if you put any dimension after select, you have to also put it after group by. We don't have any dimension after select, so we're good. We don't need group by, but we do have a price over here because we don't use group by to roll up the data from details to high level. So we don't need to aggregate the measure. So you can just put select price. That should be enough. So let's run this. So that's $3.95. That's exactly the same result. I hope this is clear to you. In fact, it should be too simple for you after you are done with the coffee chain use case. But this is still an important lesson just for you to go through this process end to end. So the second business problem. All right. So what is the sales amount of the first sale? It's just like, remember, you and 6 friends of yours and went to Starbucks, and you actually bought them all coffee. And this is when you are about to pay. And imagine that register or that employee, how he come up with the grand total. So this is the very first sale, and you bought coffee for 7 people, and 7 of you actually ordered 4 different products, if you recall. So if we break down this question, the sale amount of the first sale, what is the dimension and what is the measure? We only see, I think one dimension is the first sale, right? The first. So that's probably the sale ID. And then the measure is actually a calculated measure. So in order to calculate sales amount, I think you will need to use quantity and times price. So in fact, this is not enough. And you will need to step 1. Calculate sales. You know what? Let me just get rid of this. So quantity times price for each product. And then step 2, you need to aggregate, or you can say calculate the grand total. The total for the first sale. So to do that, we will need price and we'll need quantity. I think you remember price comes from the product table and quantity comes from the sales table. So we do need 2 tables, right? And after that, we will need, so let's actually put a step 1 here. This becomes step 2 and step 3. So we do need to filter sale ID equal to 1. Okay. So let's do that. And once again, the skeleton, it's select from and where. Okay. Do we need group by? I don't know. Let's just maybe put group by for now. Let's see. Okay. So first of all, we'll need to determine, what columns and what tables do we need. We need quantity and price and sale ID. So we know quantity comes from the sales table and price comes from the product table, and sale ID comes from the sales table as well. So we only have 2 tables, so we need them both. So we can just type product and we call product P, so P for product, and sales, and S for sales. So with that, we can just join them and using the word condition. So you can type P dot product ID and S dot product ID. What else? So remember, we need to put in the condition the sale ID equal to 1, right? So after this, we will need to determine what to put after select. So remember, we only need the grand total sales amount. But we take two steps. First step is we got quantity and times price, or price times quantity, doesn't really matter. You know what? Let's just reverse them. Price times quantity, maybe. Okay, so let's do that. Price times quantity. But after this, we will need to wrap them in a sum. So we need to give this a name. What name do we give this? We can call it, let's call it sales first. Okay. All right. Do we need group by? Actually, no, because we don't need any dimension after select. So we don't need group by. Okay. So let's try this to see if it runs. Yeah, it runs. You see how fast this is? If you need to calculate this using Excel, you have to do this, right? And this is so cumbersome if you need to do the search, and you have to use either VLOOKUP, index match, or XLOOKUP to get the price, and then do the subtotal, and then do the grand total. And this is just for one sale, right? And otherwise, you could do this for all sale. So what if we need to get this just by sale ID? Is that easy? Oh, this is so easy. Let's say we need to calculate sales amount by sale ID, and then you can just change this a little bit, and we should be able to. You don't need this anymore, but you will need group by, right? And over here, you will need sale ID. Okay, so if you want, you can do an order by too. Order by what? You can order by sale ID. Or if you want, you can order by, or in fact, over here, this, you should just call it sales. And you can order by sales and descending. So you can see who or which sale actually generates the most revenue. So if you run this, you will see. Okay, so you went with 6 friends of yours, and that was actually the biggest sale for Starbucks on that day, maybe. All right. So this becomes so useful, so useful. This script you can just change a little bit, and it can serve many different purposes. With some variations of the problem, you just need to change here and there, and you can answer the question of your boss or the question of your client almost instantly. All right. I'm pretty sure, maybe this SQL query is built into that register. So it's so easy after, the employee enter the product ID and then quantity, and then you just press the key. It's going to tell you the total, right? It's just so damn easy. Question? Oh, Song Chan asked, do we need as? I tried in SQL and SQL9, and you don't need it. Is it legacy code? Oh, okay. So just so you can put as here, you can put as here, and that's okay, no problem. And I think I remember people also ask, sometimes we put reference over here, and sometimes we don't. and what is the rule? And if you want, you can put this is price, this is P, and this is quantity, and this is S. You can put the alias before every column, and that's not a problem. So sale ID, that's S, right? And like this is sale ID, and this one you don't have to, because this is a calculated measure. And if you run it, and this should run, right? I did it the previous way only because if the price is only found in the product table, and then you don't need this, right? And if the quantity only exists in the sales table, and then you don't need AS dot. And you could always skip AS. I believe you can do this in MySQL, SQLite, SQL Server. I'm just lazy. But I think it's a good habit if you include everything, so it becomes very clear. Okay. All right. Let's do a couple more questions just to reinforce the impression that you have with this very simple data model. Okay. What about this question? So the question is the sale amount of 2 drinks. You see, we don't need to recreate everything. You can just maybe copy this and change a little bit. Sale amount of 2 drinks. So this is sale. Let's change this to total. And then the condition, we need to change it. So that should be size. And single quote or double quote, both are okay. So anything else, this should be fine. Yeah, this is correct. So 2 more questions. Let's find. So this is average price of coffee mocha. How do you handle this? Well, first of all, this is very simple question, and it involves only one table, only the product table. So let's just bring up the skeleton, select from where, that's it. And from product table, you just need price, average price. So average price, you can just put average maybe. And then price. So this is average price. And what is the condition? Only coffee mocha. So where food equal to coffee mocha. I think that's it, right? Just to make this a little more explanatory. So maybe average price, cafe, cafe mocha. How about that? Let's run. Yeah, so this is correct. And if you really want to format this with 2 decimals, you can try the trick that we used last time with coffee chain. I don't remember how to do it now. You see, the programmers or developers or analysts, they don't always remember everything, but you did that, in the previous case. In some case, you will just dig up the coffee chain and then just copy the part from that example. If you really want to do it now, you can, right? I mean, and okay, let's forget it, because we still need time to do the second case. Just one more, just one more. The sale amount of tall coffee mocha. All right. So once again, you don't have to do this from the beginning. Why don't you just copy the first one? All right. So there are two conditions, I believe. The first condition is food is cafe mocha. And the second condition is size is full. All right. And this all works, except we need to change the name to sales, maybe tall cafe mocha. Oh, sorry. All right, let's run this. Yeah, it's pretty easy, right? Okay, so I think we're good now. What's next? I want to show you how can we use SQL to do this? Do what? How can we use SQL to do this? So changing from white shape to long shape. And this is called unpivot. So if you realize this is actually pivot, how do you know? You know, it's actually pretty easy. So if you select this table, and if you go insert pivot table, just from this, and let's put it here. So if you put food here, and size here, and price here, you know what? You get this table, and this is a pivot table, right? This is a pivot table. And that's why I really don't like the crosstab. So you put food, one condition in the row, size, the other, so not condition, one dimension one in the row, and column, the other dimension. And then you have a crosstab. And over here, if you want different stores, you can put store over here, or with different months, you can put it all here. But this is essentially the Y shape, and I hate it. I don't like it. So if you go from long to Y, that's called pivot. So I think that's understood. But if you do the opposite, going from Y to long, that's called pivot. So that's the opposite of pivot. Can we do pivot using SQL? Yes, you can. Yes, you can. So probably I'm not going to. We can do it within MySQL, or we can do it in SQL9. Let's do it anyways. Let's do this. Okay, what we need to do is let's just go to my SQL. What do we want? Okay. So this product table, let me just copy this, but we give it a different name. Let's give this a different name. It's the same table, but let's just give it a different name. First, let's do pivot. Let's call this product long. All right. And let's just get the same data. All right, let's call this product long. Run. Okay, let's double check. Select star from product. Oops. Long. Yeah, so it's here. So now let's do pivot first. So how do you do pivot? Let's do this one by one. It's not that straightforward, but if we break it down, it becomes easy. Has anyone worked with case when? So case when is quite often seen in SQL. Let's just put the skeleton first. So select from, in this case, there's no filtering whatsoever, but we do need, we'll do group by maybe later. So let's select from product long. So what do we need here? If we really want to get, this, then we can do it one by one. We can get this first. We can get tool first, and then grande, and then vinti. How's that? So we can get tool first. Let's go back to. So what we can do is we want to get tool, right? We want to get tool. So what you can do is use case when. Case when size equal to tool, and then get the price. Otherwise, else, no. And you always need to put an end here. So let me just repeat this. It's case when if the size is tool, and then let's get the price. And if the size is not tool, and then we can just put no. So we can name this whole new column tool. So let's run this to see what we get. See tool, all of these, and that's when the size is tall, right? When the size is not tall, you get all the null here. So how can we get rid of the null? We can do this. So now it's a good time for us to put group by. Let's do group by. Root. And then we need to aggregate this because this is price. So it's a measure. We need to aggregate this. So what you can do is you can put a maximum. So if you see both a number and low, the maximum of them all should be a number. So let's just do a max and put the whole thing within the bracket. Okay, now let's run it. So then the null is gone, right? So this is just total. We can create the same thing for grande. So this should be, and this is grande. And let's do another one. So this should be vinti. So make sure within quote, this is uppercase, but for the name, you see all the name I use lowercase, so that's fine. All right, so let's do this. Oh, here. So we can't have comma between select and from. So you see, but you forget food. That's so true. Remember the dimension you put after select and show up after the group by. Yeah. So what is this? This is pivot. So now let's do pivot. So pivot, actually it's more straightforward, but we will need to create the white shape. It's a shape that we hate. We start to hate from this session and forward. So I'm not going to spend too much time. We can just do create table, that's product wide, opening and closing bracket. Let's put a semicolon over here. So we should have food. This is broad chart, 55. And then you have total. Remember, toy is a value of the size, but now it becomes the name of the column, right? Which is bad. So let's do float. And we also have grande, also float. And we also have inti. That's it. Let's run this. Okay. So I don't want, so let me just pipe this into product white. And then we have values. So I don't want to type one by one. Let me just copy paste. Oops. Wait a minute. Can we do this? Yeah. Okay. Let's indent. Okay, so this works. Let's do a select star from product wide. Okay, so it's working. All right. Now, let's do unpivot. How do we do unpivot? If we go back here, we could also break it down and do it one by one. So we can do this part first, and then this part, and this part. So we can do this for total, and then grande and venti. So let's go back. Oh, it's actually pretty straightforward. So let's put the skeleton first. Select from, and yeah, that's it. Select from. So it's definitely from the product table, product white table. That's the only table in this case. And what do we select? So we need food, and then we need one column at a time. So what we can do is size, price. So we do need this column and this column, but we need to specify the size being told, right? The size being told. So let's go back here. We can just type total as the size. So we just hard code. It's all total. And then we'll get the total price. I don't know if this appears straightforward for you, but just think about it. We want to get this total column, but we know this is, sorry, we want to get the total column which contains the price, and we know this price is for the total size, right? Okay, so after this, let's just run it. Yeah, so this works. So this is hard coded into this column, so it's for total. And if we get the price, with the total column, so that's the price for total. So we can do the same for the other two columns. Okay, sorry. We just finished this part, and we can do the same for Grande and Venti, okay? And after that, we can just stack them, right? There's a way to stack them within MySQL or SQL9. So I think some of you already think of union, so we can use union. So let's do this 2 times, right? The only difference is we are going to name this Grande. So this should be Grande price, and this should be Venti. And this should be Venti. Okay, but let's test this. Yeah, so this is Grande price, and this is the Venti price. So now what we need to do is we just union them. What's union? Union is just stack the 3 tables up, down, right? Up, from top down. So we will put this on top of this, and then on top of this. Okay, so we don't need this, but this is the end. We can put a semicolon over here. So you can just type. There you go. So you can have all of them together. Yeah, but if you need to sort them, you can. So I'm going to pause here, and we'll just finish the Starbucks use case. And it may look a little weird because I introduced 2 data structure, one good, one bad. The bad one you're already quite familiar with, but you might think it's okay. But from now on, I want you to hate it. I want you to think of data the way the machine think of data. The machine hates the wide format because it's really hard to, you see how hard it is just to do anything with it, to calculate average, to across multiple columns. That's just such a hassle. But once you have the data in long format, everything becomes so easy. Just remember the long format. There is one golden rule, which is every dimension has its own column, but only one column. And every measure has its own column, but only one column. Okay. Are we good so far? Think we're good? So I'm not going to keep this. It's exactly the same as the script. So I will just delete this. Or maybe I just insert another page. I want to show you the second use case. It's called deposit. It's called deposit. Let's go to MySQL. And this is actually a real test from a company called Capital One. Just keep this to yourself. And Capital One is probably using this same test to screen candidates. We have seen this test over and over again, through our students. And I thought this is a really good case. And it's in financial service industry. And we can use it to illustrate the process whenever you receive the task from the employer. And this is the technical round, and you just have to do a good job in order to make it to the next round. Otherwise, you don't get to see the hiring manager. So how do we do well in coding tests? And how can we handle the technical round? First of all, it's important that you can solve the problem, but it's not enough solving the problem. And you have to make sure you do it the right way and the professional way. Guess what? For every position, probably there are one-on-one candidates who can solve the problem. But if you really want to win the job, you just have to do something extra. But before this, I really want to say one thing. Many candidates, they claim themselves to be data analysts or business intelligence analysts. But whenever they receive a coding challenge or technical test, they just simply can't handle it. So you have people who don't respond to the test. It's like, they apply for the job and the employer sent them a test, but never hear back from them again. So they just don't have the courage to write the test. But you also have people, and they like the job, they want to try their best. So they tried their best and submit the result, but they don't hear back from the employer, and they don't know what's wrong. Many times they thought they solved the problem, but how come they don't get to the second round? So I want to tell you that there are just so many mistakes and people make, and they don't know they made those mistakes, and they thought, if they solved the problem, they should, be selected for the next round. No. So I want to show you the proper way to handle a coding challenge, and this is the proper way. So just give me 1 second. Let me just go back up to deposit. Yeah, this is the one. Okay, so I want to show you in MySQL first. So if you look at the task, it looks quite simple. The task looks quite simple. So using SQL and create a table to identify customer ID, customer who reached the cumulative minimum deposit of $500. And after you answer the first question, the second question is the deposit date. So on what day the customer hit the cumulative minimum deposit of $500? You have no idea about this problem, what it asks you to do, unless you look at the data. So a lot of times when the candidates receive the problem, they are trying to code SQL in a very abstract way in their mind. and without real data to test the code. That's mistake number one. You just have to use the sample data the employer gave you, or if they don't, you will need to create your own dummy data just to test the code before you know for sure you solved the problem. And it's actually a good thing if you show the employer the entire process, how you create a database, create the schema, and then solve the problem. So this is the process. Create the database and create the schema and then solve the problem. Step 1, 2, and 3, just like dancing, okay? So let's try to solve this problem. If we look at the data, and this will become clear, okay? Let's run this first, and then let's try to copy from this solution. Let's create a database. Okay, so now let's refresh this. You have the deposit database. Let's create the schema. So including 2 steps, create table and then insert into the table the sample values. So there are 2 tables. The first table is account and the second table is deposit. And then you insert some sample data into account and then into deposit. In fact, I can get rid of this just to make it simple. Yeah. So let's run this one by one. Create table, create another table, and insert some sample value and into the first table and insert some sample data into the second table. So if I refresh the schema, here you see 2 tables, account and deposit. Let's open the account table. Okay. So I believe everyone in the audience, you have a bank and you probably have more than one bank account. And most of us have a checking account with the bank. And some of us also have savings account. I don't know if you know the difference between checking and savings. The difference is checking account gives you the access to cash. And it's very, very convenient. So you can have a debit card linked to the checking account, or you can write a check, against your checking account, or you can go online. You can use your checking account to pay bills. So checking account is for you to access cash, but checking account and the balance sitting on the checking account doesn't earn any interest at all. Okay, what's savings account? So savings account actually earn interest. Savings account, you could have what we call the high interest savings account, HISA, high interest savings account. Now I think you get a higher interest, but a year ago or maybe a year and a half ago, the high interest savings account probably gave you 0.5% interest rate, because the bank accrue interest every day, and the savings account you can move cash away from the savings account and anytime. So the interest rate is low only because you didn't fix the term. You also have GIC, and so GIC has different terms, maybe 3 months, 6 months, 12, and because you cannot break the term. If you break the term, you lose the interest. So the bank is able to give you higher interest rate. So savings account is different from GIC because it doesn't have the term, and you can move cash in and out of savings account. So oftentimes you maintain 2 accounts, and if you don't need the cash, if you don't use it, you can move the cash into savings account, but you always maintain minimum balance on your checking account, so it's enough to pay the bills. And just make sure the balance doesn't go below a certain level. And otherwise, if you have pre-authorized debit, and if the bank is trying to deduct certain amount from your checking account, but the balance is not enough, and then you will have not sufficient fund, or maybe you wrote a check and the check bounced, and that's going to look very bad on you. So for that reason, many people maintain very high balance on the checking account, and just so you know, you're giving the bank free cash, and the bank can actually turn around and use this free cash to write mortgage loans. Yeah, they can do that. Yeah. Okay, so now that you know the difference between checking and savings, I want you to look at this table. This simple table has 3 columns.